Hello everyone, welcome back. In this video, we're going to learn about member functions, specifically member functions that are part of the vector data type and how we can use them to help us solve problems using vectors. For our warm-up task today, just go ahead and open up our vectorfun.cpp in gedit that we're working on in our most recent video. This is what vectorfun.cpp looks like. We're going to add code to vectorfun.cpp in this video to make use of some new vector functions that we're going to learn. So first, let's talk about member functions and what they are. We've actually been working with member functions a lot this semester, and we probably didn't realize they were member functions. Typically, when you call a function, let's use rand for example, you specify the name of the function, open paren, close paren, and if there are any arguments you want to pass into that function, you specify them in between the open paren and close paren. This will cause the rand function to execute. Now, what makes a function and a member function different? Here's an example of a member function. The name of the member function is open. We have open paren, close paren in order to invoke the function. If there were any arguments we needed to pass in to the function, we would specify them here inside of the parens. But something that this function call has that this function call does not have is this part right here. The name of a variable and a dot. Let me show you a few more example member function calls that you have seen in this class. Let's say we have a string variable called myString, and we want to figure out how many characters are in myString. We'll do myString.size. Size is the name of the function. Here again, we have the name of a variable and a dot preceding our function call. A few other member functions that we've used in this class include open, good, fail, length, at, etc. There are actually quite a few that we've used. Perhaps you've wondered why we have this little bit different syntax for those functions than we do for some other functions, like rand, or really any function from the CMath library, or any function that we've defined. When we define a function, in order to call it, we don't have to put a variable and a dot in front of it like we do to call these member functions. Member functions are called member functions because they have membership or they belong to something called a class. Now, in Computer Science 122, the next class after 121, you're going to learn about a very, very important topic in computer science called OOP, Object-Oriented Programming. In OOP, you can define your own data types called classes, where you can specify the behavior, which would be the functions, and the state, which would be the data, the variables, associated with an object together in the same data type, which is really cool. Stay tuned to 122 or learn about OOP on your own in order to find out more about how functions can belong or be members of classes. For 121 purposes, we're going to say that member functions have this particular syntax. Where I'm using the hard brackets here as placeholders. So this is a placeholder for the name of a variable. Then we have a dot, and then we have the placeholder for the name of a function. And then we have open paren and close paren. This is how we invoke a member function. And this is pretty much all in 122 that in 121 that we're going to talk about member functions. Just say, here's how we invoke them. Their syntax is different from, say, a standard non-member function, where we just specify the function name and the open paren, close paren. There's no dot and a variable name in front of it. So we're talking about member functions because we're going to learn about vector member functions. For example, there is a vector member function, just like the size for string. Let's say we have a vector called myVector. We can get the number of items in the vector by calling myVector.size. We saw this in the last video. We could also get an item at a location that has bounds checking using the @member function. We saw this in the last video as well. So the size member function knows which vector to return the size of because this vector is the one invoking it. The @member function knows which vector to get the first element of because this vector, myVector, is invoking it. That's what this variable name dot in front of the function does. Essentially, it says this function is going to operate on this vector or this variable. All right, so let's head back over to the notes and take a look at all of the different available member functions that is covered in the Gaddis textbook that we can use in our programming. So there's @, which we've already seen. One thing I want to note about is it's the preferred method to get an element or access an element in a vector because it performs the index bounds checking that we saw in the last video. There's also size, which will tell us how many items are in a vector. There's pushback and popback. Pushback will push an item to the back of the vector. This is also known as appending an item. This doesn't overwrite the last item in the vector. Instead, it grows the size of the vector by 1 by appending or adding another item at the end of the vector. We'll see examples of this here shortly. Popback kind of undoes pushback. It pops or removes an item from the back. This is also known as last item remove. And this shrinks the size of the vector by 1. So it doesn't simply zero out or clear out the last item. It actually physically removes it from the vector. There are more member functions than these 4 listed here. If you take a look at the Gaddis textbook, there are additional ones that are listed with the description. I highly encourage you to check these out. For example, some useful vector member functions include clear, which will clear a vector of all of its items. So it's like essentially calling popback until there's no more items to pop. Empty is a predicate function. It will return true if the vector is empty, false otherwise. Reverse is also a helpful member function. It will reverse the order of the elements in the vector in place. These are just examples of vector member functions. There are more vector member functions than listed in this table from Gaddis. You can always head over to like c++.com and take a look at all of the vector member functions if you're interested. Now let's head over to vectorfun.cpp and let's see some of these member functions in action. Let's work with the words_to vector. Words_to only has 2 strings in it, hello and goodbye. I'm going to comment out this line of code here where we were printing out words because this causes our program to crash. And I'm going to work below it. So let's add a word to the back of words_to. Recall words_to has hello and goodbye in it. So let's first print out the size of words2, so we have a reference. Then let's use pushback in order to add a new word to the back of the vector. And I'm going to add the word, I'll do summer. Then let's print out words2.size again, so we can in fact see that pushback grows the size of the vector by 1. And then I think we should print the vector out so we can see summer at the end of the vector. All right, here's our size right here. Words2 had 2 items in it. Then we push back to add summer, and we got 3 items. And then we print out the contents of words2, and we see hello, goodbye, summer. Awesome. Now let's remove a word from the back of words2. I'm going to go ahead and just copy this code here because it'll be easy to adjust. Instead of pushback, we're going to use popback, which does not accept an item to add to the vector. Okay, so we see here the size of words2 was 3, then we pop back, and the size became 2, and we print out the contents of the vector element by element, and we see that summer is now gone, and only hello, goodbye is here. Let's check to see if words2 is empty or not. We could simply query the size and see if it's 0, or we could see what words2.empty, calling the member function, returns. And it returns 0, which we know stands for false. Now let's clear out words2, and then let's see if words2 is empty or not. And after clearing it out, words2.empty returns 1, which we know represents true.